Hello everyone, I am Saranya Bajaj and welcome back to Math Made Simple. Today we're diving into the world of linear differential equations. Don't worry, it's not as scary as it sounds. In fact, by the end of this video, you'll know what linear differential equations really are, how to solve them, and even how to solve them with a secret weapon using an integrating factor. So let's dive in. First things first, what is a differential equation? So, a differential equation is just an equation which involves derivatives. For example, this. This is telling us how the function of y and its derivatives are related. Now let's talk about order and degree. Think of it as like levels in a video game. So essentially, order is the highest derivative in the equation. So let's take this equation for example. Here, d square y by dx square plus 3 dy by dx plus y is equal to 0. In this equation, the highest derivative occurring in the equation is d square y by dx square. So therefore, the order of this equation is 2. Order is basically if however length to y is differentiated. Let's say when we differentiate y once, then it is dy by dx. If we differentiate it twice, then it's d square y by dx square. In this equation, the highest derivative of y is 2. Therefore, the order of this equation is 2. This is telling us how the function of y and its derivatives are related. Now, degree is the power of the highest derivative, provided the equation is a polynomial in derivatives. So, in this equation, dy by dx whole square plus y is equal to 0. Here, the derivative is squared. Therefore, the degree is equal to 2. If we talk about order in this equation, here there is only one derivative that's occurring. Therefore, the order is, and you guessed it right, 1. Because why? Y is differentiated only once. And taking that into consideration, dy by dx is the highest order, highest and the sole derivative in this situation. Here, the derivative is squared. Therefore, the degree is 2. Now comes the most important part of them all. How to identify a linear differential equation. I'm going to tell you a golden rule. An equation is linear if the dependent variable y and all its derivatives appear only in the first power. No squaring, no cubing, no funky stuff. Example, this. Here, the first example, dy by dx plus 2y is equal to cos x is linear. Whereas the second example, dy by dx plus y square is equal to 0 is not linear. Can you tell me why? In the first one, it is just multiplied by 2. The y is just multiplied by 2. So therefore it is linear because 2 is also a linear term. Whereas in the next equation, it is squared. Y is squared. Therefore it is not linear. So basically, if your y and its derivatives behave politely, no powers, no products, you've got a linear differential equation. Alright, now for the magic trick. To solve these given linear differential equations, we use something called an integrating factor or IF. Now here's the recipe. Start with an equation like this. Now to find the integrating factor, we take the coefficient of y, which is p of x, which is a function of x alone. Now to compute the integrating factor, we take this equation where integrating factor is equal to e raised to the power integral of px of dx. Now, whatever after the integration e to the power, that will be your integrating factor. Now, that integrating factor, when you multiply it with the entire equation, suddenly the left side becomes a perfect derivative. It turns into this. d by dx of y into integrating factor is equal to q of x into integrating factor. Now, when we integrate both sides, and boom, you've got your solution. Let's do a quick example. So here, this equation, dy by dx plus y is equal to e to power x. Here, if we compare it to the standard form, p of x is equal to 1. So, the integrating factor will be e to power integration 1d of x, which is e to power x. When we multiply throughout the equation, e to power x dy by dx plus e to power x of y is equal to e to power 2x, because e to power x into e to power x is equal to e to power 2x. That will give us this. Now when we integrate both sides, we will get y e to power x is equal to e to power 2x divided by 2 plus c. So finally, our answer is here. Y is equal to e to power x divided by 2 plus c e to power minus x. Done. Easy, right? So today we learned what order and degree mean, how to spot a linear differential equation, the standard form of a linear differential equation, and how to solve it using integrating factor. Now next time you see one of these in your exam, you'll smile and say, gotcha.
Hello everybody, my name is Pratishruti and today I'm gonna explain what reducible to linear actually means, right? So, here's a quick question. Have you ever faced something in life that looks so complicated at first, but once you reframe it, it becomes simple? Well, that's what reducible to linear actually is in maths. You take something non-linear and scary and transform it into a nice, sweet, solvable linear equation. So, I gave you an overview. Now let's understand, what does reducible to linear even mean? So, a linear differential equation looks like this, right? That's linear in y because y and its derivative only appear to the first power. But many times we face equations where y shows up as y square, 1 by y, or something even weirder. If we can apply a substitution to remove that mess and rewrite it in a linear form, that's what we call reducible to linear. Right? Now let's understand with an example. So here's a classic example, right? Do you see this equation? This equation is called a Bernoulli equation. Looks non-linear because of that y to the power n. But if I divide through by y to the power n cleverly and substitute v equals y to the power 1 minus n, boom, it transforms into a linear equation in v. So, even though it started non-linear, it's reducible to linear. Think of it like taming a wild Pokemon. It's suddenly following orders. Let's understand with another example, a very easy case. Now, for example, take this equation. That square makes it non-linear. But if we substitute v equals 1 by y, then dv by dx minus 1 is equal to 1. That is linear. And so much easier to solve, isn't it? Now, one question that every student pursuing maths asks on a regular basis. Okay, this is a textbook question, this is a textbook answer. But where am I gonna use this concept of reducible to linear in a real life? Well, don't get me wrong, there are multiple uses of this particular thing in our day-to-day life. Now let's take an example of the first three that I can think of. So the first one being physics, right? So Bernoulli equations show up in fluid mechanics and motion. Reducing them to linear makes stimulations possible. Now second, me as an economics student, nonlinear cost or utility models sometimes simplify to linear, helping economists predict trends instead of like crying over the multiple graphs that we have to go through. Now, third one is biology. Now, logistic growth equation reduced to linear forms, making it easier to model populations, right? Now, that brings us to the end of all of this. So here's the big idea in a conclusion. reducible to linear is equal to finding the hidden simplicity inside chaos, right? Now, like untangling your earphone, very messy at first, but pull that right string and it's straight. That's why I find math so cool. It teaches us that even the messiest problems in life can sometimes be reducible to linear. Thank you.
Hello everyone, my name is Ribhav and I'm here for the third and the final part of the video. So, as Pratishruti mentioned in the second half, what reducible to linear equation questions can be about, I'm here to help you identify these questions when they're in front of you, as well as how to deal with, say, some tougher reducible to linear equation questions. So, as mentioned by her, reducible to linear equation questions may look super scary at the first glance, but when I first saw them, I was like, why reduce anything at all? Why can't we just solve it normally by, homogeneous, variable separable, as well as other methods that we have? But reducing equations to linear is exactly similar to reducing your phone bill or reducing the cost of your travel. It makes your life much easier, doesn't it? So it's simply as simple as that. Now imagine that you have an equation. So over here, the dy by dx plus p bracket x into y equals q function of x y to the power n. This is what we call a Bernoulli's equation. Now, if you can say if n equals 0 or n equals 1, congratulations, you already have a linear equation. Nothing to do. Go eat some pizza and have fun with your friends. But if n is not equal to 0 or not equal to 1, then this is a wild Pokemon, like she mentioned before. So it looks dangerous, but you can still catch it. Trust me, you can. Using the magic substitution v equals y to the power 1 minus n. This is the basic substitution trick that you want to use in these type of questions. Whoa! So, what do we have here? This is an equation where the value of n equals 2, which means it is not equal to 0 or 1, which gives us a clear indication that this is a problem of reducible to linear. Now, at the first glance, the question may look extremely difficult and confusing. However, using these steps, we can easily prepare a simple linear equation and get the answer. I'll be explaining how. So, for the very first step, we will put v equals y to the power 1 minus 2, the simple substitution formula that we got to know about. The very basics, alright? Now, moving on to the second step, differentiating this. When you differentiate it, we get minus y to the power minus 2 dy by dx. The reason dy by dx comes over here is because we are integrating or differentiating it with respect to x. Now, moving on to the next part, we simply rearrange and differentiate it. Now, after differentiating it, we substitute it back to the original equation. We get minus dy dv by dx plus 2 by xv equals x cubed. Now, for your simple understanding, we rearrange it, and we know for a fact that dy by dx can never have a negative coefficient, for which we have got a simple linear equation. Now, as mentioned by Saranya, our integrating factor is the best friend in this question. Over here, we find the integrating factor by taking e to the power whatever this value is. Alright, that is x square. Now, this is our integrating factor. We multiply integrating factor with b equals to the integration and minus x squared by 2 plus c. Now, substituting back the value of v, we get the equation. Yes. Now, this is the final answer. Whoa, gotta stop doing that. Anyway, so that's it about for this video. I hope you had a great time learning